Introduction. Every time we move something, use our pencil or walk, we are using force. Think about how many times you would lose your papers if inertia didn't make it stay where you put it. Objectives. At the end of this lesson, you'll be able to define force, distinguish between balanced and unbalanced force, Newton's law of motion, relation between force and the state of motion attained by it, understand the conservation of momentum, force and its types. The object will undergo change in its direction, speed or shape only if force acts on it. Hence, force is defined as: force is any influence that causes an object to undergo a change in speed, a change in direction, or a change in shape. Force is a vector quantity. Force is of two types, balanced and unbalanced. Balanced force means two forces are acting on opposite sides of the body, and that body does not change its position. Example: a block pushed from both the sides with equal force. Unbalanced force is one that is not opposed by an equal and opposite force to cause a change in the object's position. Example: when block with great force on one side. Newton's first law of motion. The book will not move by itself. It will change its state of rest only when force of hand acts on it. This explains us the first law of motion. First law of motion states that a body will remain at rest and a body will remain in motion until and unless external force acts on it. Application of Newton's first law of motion. When a bus starts suddenly, the passengers fall backward because of inertia. The passenger tends to remain in the state of rest even if the bus has started moving. Inertia is the property of the body due to which it resists the change in its state of rest or of uniform motion. Mass is the measure of the inertia of a body. Larger the mass, greater is the inertia. Example: when the car stops suddenly, the driver is jerked forward because of inertia. The driver tends to remain in state of motion even if the car has stopped moving. Newton's second law of motion. Newton's second law of motion states that the force acting on the body is directly proportional to the mass of the body and acceleration produced in the body in the direction of the force applied. F is equal to m into A, where F is equal to force, m is equal to mass, A is equal to acceleration. Units of force. The SI unit of force is Newton. Newton is defined as the force acting on the body of mass 1 kg, producing an acceleration of 1 meter per second square. Unit is equal to kilogram meter per second square, or Newton. To calculate force of body having mass 1000 kg and acceleration of 0.5 meter per second square, then F is equal to 1000 into 0.5, which is equal to 500 Newton or kilogram meter per second square. Application of Newton's second law of motion. Cricket player lowers his hands along with the ball to catch it because the acceleration of the ball gets reduced and hence overall smaller force is applied to stop the ball and no injury is caused to the hands of the player. Momentum. Momentum is mass in motion. P is equal to m into v, where P is equal to momentum, m is equal to mass of the body, v is equal to velocity of the body. SI unit is kilogram meters per second. Hence, combined effect of mass and velocity is called momentum. It is a vector quantity. The change of momentum of an object is proportional to the applied unbalanced force in direction of force. Formulation of second law of motion. The change of momentum of an object is proportional to the applied unbalanced force in direction of force. Let the initial momentum be P1, which is equal to mu. Let the final momentum be P2, which equals mv. The change in momentum is P2 minus P1, which equals mv minus mu. Rate of change of momentum is m into v minus u whole upon t. Force is equal to k into m into v minus u whole upon t. Force is equal to kma, where k is the proportionality constant. Newton's third law of motion. Whenever one body exerts a force on another body, the second body exerts an equal and opposite force on the first body. Every action has equal and opposite reaction. Examples to illustrate Newton's third law of motion. How do we walk? When we walk on the ground, our foot pushes the ground backward, and in return, the ground pushes our foot forward. Why the cannon recoil? When ball is fired from a cannon, the force sends the ball forward and is equal to the force sending the cannon backward, hence the cannon is said to be recoiled. Jet aeroplanes and rockets. The action of the gases downwards of the rocket gives equal and opposite reaction to the rocket to move upward with great speed. The case of hose pipe. The fireman directs a powerful stream of water. They hold it tightly because it has tendency to go backward due to the backward reaction of water rushing in forward direction. Law of conservation of momentum. When two or more bodies act upon each other, their total momentum remains constant when no external force exerts on it. Is called law of conservation of momentum. Momentum is never created or destroyed. It is also called principle of conservation of momentum. Let two objects of mass ma and mb traveling in the same direction have initial velocities as ua and ub respectively, and their final velocities be va and vb respectively. The rate of change of momentum of ball A be FAB, which is equal to MA into VA minus UA upon T. The rate of change of momentum of ball B FBA is equal to MB into VB minus UB upon T. According to the third law of motion, every action has equal and opposite reaction. Hence, the force exerted when both objects get coiled is FAB is equal to minus FBA. On solving, we have MAUA plus MBUB is equal to MAVA plus MBVB, where MAUA plus MBUB is the total momentum before collision and MAVA plus MBVB is the total momentum after collision. The sum of the momenta of the two objects before collision is equal to the sum of the momenta after the collision when no external unbalanced force acts on it. Momenta is the plural form of momentum. Did you know? Sir Isaac Newton sought to describe the motion of all objects using the concepts of inertia and force, and in doing so, he found that they obey certain conservation laws. Equilibrium occurs when the resultant force acting on a particle is zero. In systems where objects are moving with different velocities, it is impossible to determine which object is in motion and which object is at rest. In other words, to phrase matters more technically, the laws of physics are the same in every inertial frame of reference, that is, in all frames related by a Galilean transformation. Weightlessness when in free-fall orbit around the Earth and Newton's law of motion are more easily discernible in such environments. Summary. Let us summarize what we have learned. First law of motion. An object will be in the state of rest or in motion until external force acts on it. The mass of the object is a measure of inertia. Force of friction always opposes the motion of objects. Second law of motion. The rate of change of momentum of the object is proportional to the unbalanced force in the direction of force applied. The SI unit of force is kilogram meter per second square. Third law of motion. Every action has equal and opposite reaction. The total momentum is always conserved.